Alrighty, today we're going to be talking about lesson 9. So this is half of lesson 9, and then you'll do the other half I think I have on Wednesday. It's about exponential growth and decay, but the difference is we are going to be doing word problems rather than just straight solving. So a couple different things. Here's your exponential growth equation. So f of t is equal to a times 1 plus r to the t. A is your initial amount, r is your growth rate, and t is your time. There's a little star by growth rate because you need to make sure that you always change your percent to a decimal. And you do that by moving over the decimal place to the left, or you divide by 100, whatever you need to do in order to actually figure it out. So in the examples, it's going to ask you to do two different things, technically three. So you just need to make sure that you're labeling all of them. So it says the original investment is $1,800. If the value has increased by 7% each year, they want you to write an exponential function for the model. So they want you to do this first. So here's step 1. My original amount that I invested is A. We are increasing at a rate of 7%, so that is R. They want you to write what that equation would look like. So to start, we're going to do f of t is equal to my initial amount of $1,800. And we'll do 1 plus my 7%. You move it over 2 to the left, and you get 0.07. 0.07 to the t. That's the first thing they want you to do. That is a model of the situation. So then the second thing that they want us to do is they actually want to know after 15 years, which is t, what has it increased to? So it started 1800, what did the number increase? Say f of 15, because that's what I'm plugging in for t. And we'll do 1800 plus, or times 1 point, wow, I can't even talk, 1800 times 1 plus 0.07 raised to the 15th, and we're trying to figure out what that is equal to. So if we were to plug this into our calculator, I literally will type it in, oops, it's the same thing I just clicked, as you see it. We'll do 1800 times 1 plus 0.07, and you are going to raise it to the 15th. Now we're talking about money, so money is rate is rounded to 2 decimal places, so I would say my final answer is 4,966.26. And then the way that you can write your final answer, whoops, that's what I want, is 4,966.26 cents total after 15 years. Okay, so same thing over here. They want us to go through, and it says in 2002, there were 972 students enrolled in Oakview High School. Since the number then, the students has increased to 1.5 each year. Write an exponential function to represent the model, then find it in 2014. So to start, I'm starting with 972 students. That's my A. I have 0.5%, which is my R. So step 1, or the first thing they want me to do, say f of t is equal to the 972 kids that I talked about. We'll do 1 plus, and then if I have my 1.5, move it over to the left, I get 0.15. I'm going to raise it to the power of t. That's step 1. So step 2, they want us to know what's the enrollment after 2014. Now, I can't just say that this is my t. I'm starting in 2002 and I'm going to 2014. So that means my t has to be 12 years because there's 12 years from 2002 to 2014. Okay, you plug it in, raise it to the 12th. Now, you do this, since we're talking about people, we shouldn't have a decimal for a person. Okay, so we have 972. And then we'll do 1 plus point, that's not a point, 0.015, raise it to the 12th. So since we can't have a decimal, I would say it's about 1,162 students, give or take. And that would be your final answer. We're going to do the same thing for decay. So if you notice, my equation is basically identical. The only difference is that I have a minus sign instead of a plus sign. So my A, my R, and my T represent the exact same thing. So an investment of $12,000 is losing value out of a rate of 4%. So here's my starting value. Here's my R. They want me to write a model for the situation. So here's the first thing I need to do. So I'm going to do f of t is equal to the $12,000 I invested minus my 0.04% because I have to move my decimal over 2 to the left. I'm going to raise the power of t. Second thing is they want to know what's going to happen after 9 years. So how much money lost of the duration of a 9-year investment. So think of a car in a sense. Your car loses value after you've had it for years. Whoops. $12,000. Do 1 minus my 0.04. And I'm going to raise it to the 9th. And now my car, after 9 years, is only worth $8,310.41. I would say total after 9 years. So if you notice, let me go show my answer. Each time I'm doing also including what my unit is, so you need to make sure that you're including that as well. All right, one more. Okay, so it says Mark bought a brand new car for $35,000 in 2008. The car depreciates, which means decay, at approximately 8% per year, which is my R. They want you to write an exponential model for the situation. So here's the first thing they want me to do. I would say f of t is equal to the $35,000 I spent on my car times 1 minus my 0.08 raised to the t. Okay, so then for the second thing, I'm going from 2008 to 2015, which is 7 years. How much would my car be worth 7 years after I purchased it? Let's see what we come up with. So I have my $35,000 times 1 minus my 0.08. I'm going to raise it to the 7. My car is only worth $19,524.63. So this would be the total value in 2015. So, for you, that's what most cars we can afford are. Okay, so that's the first part of lesson 9. You'll get the second part, which is compound interest, in the second part.